Alright, section 6.1 is on page 374, talks about exponential functions. If b is bigger than 0 and b not equal to 1. So basically, we're choosing a number, b. We want it to be bigger than 0 and not equal to 1. Then, y equal some constant times b to the x is an exponential function with base b. So this b is the base, that's the key, and that base is either between 0 and 1 or bigger than 1. Exponent is called x, it's right there. That could be any number. There's no restriction on that. Now, if I replace x by 0 right here, if I replace x by 0, do you see that y would equal c times b to the 0? And what's any number raised to the 0 power other than 0? Isn't that a 1? So the point 0c is a must. This c, if you let x equal 0, is called the initial value. Very useful. So first set of problems on page 384, we want to identify out of those, which of those would be exponential functions. Well, let's see. We want a base that is a number. This exponential functions, this doesn't work. The base is a 7 raised to a variable. Yes, that one checks. The base is a number, but it's not bigger than 0. No. Again, we want the base to be a number that's bigger than 0, not equal to 1. Either between 0 and 1 or bigger than 1. There is a base of 4 over 7. It's between 0 and 1, and that's a variable. Yes, that checks. That's an exponential function. There is a base. It's right there. The negative is not part of the base, so this one checks. There is a base. The base is pi, which is roughly 3.14. Raised to a number, yes. 1 is not allowed because 1 is the exception. We said if the base is a number bigger than 0 and not equal to 1. And we have a number raised to a variable. The base happened to be an 0.8, which is a number between 0 and 1. That's allowed. So those are functions. What do we do with those? Well, before we graph them, first we want to evaluate them. Evaluate the following exponential functions. If I have this as an exponential function, and I want to get used to figuring out what these values are, f of 3 is 8, and recall, there's x, you're going to put in a 3 there. F of 3 will be 8 times 8 is 64 times 8. What is that? 32, 48, 512. If the number is too big, you could leave it as 8 to the third, I don't mind. F of negative 2. F of negative 2 means you're going to take negative 2 and put it in the power. The base is not going to change. And what do you know about negative powers? They always move. So this is 1 over 64. And if I look at f of 1/2, the same deal. I don't like that 1/2. If I look at f of 1/2, that would be 8, and wherever you see an x, you put a 1/2, and we know what that is. That is the square root of 8, and that's 2 radical 2. There, straightforward. If I move to the next problem, problem number 8, here's an exponential function. Here, I'm just going to replace this x by that 5, so the negative 5 will copy in every problem. If I start with what's c evaluated at 4, that's going to be a negative 5 raised to the 4th. Keep in mind, the negative is not included, so if I take 5 to the 4th, 5 times 5 is 25, times 5 times 5, 5, 25 times 25, what is that? $625. Okay, so it's going to be negative 625. And if I want to take c of negative 2, again, I'm going to replace the x by a negative 2, something to get used to. Order of operations, parentheses is done, exponent, so that's negative 1 divided by 25, a very small number. Exponentials happen to grow very fast or decay very fast. C of 1/2 would be wherever you see an x, you're going to put in a 1/2. So that is negative 5 to the 1/2. That would be negative the square root of 5. Again, if they wanted the negative to be included, they would have put it in parentheses. They didn't, which means that exponent of x belongs to the base, and the base happened to be just a 5. Just like here, the base is an 8. The next problem I'm looking at, the base happened to be 18. The only thing that's going to change is that value right there. So when I say find h of negative 3, that would be 18 minus, and the only place where things are going to change, you're going to put on minus 3 there. H of negative 3 is going to equal 18 to the third power. Again, if it's such a large number, you could just leave it like that out of mind. If I want to find h of 2, that is 18 minus, the only value that's going to change is what I highlighted in yellow, and that's be 1 over 18 squared. Again, that's a large number. You could leave it like that. You're welcome to use a calculator for the homework. And if I take h of 1/2, that's going to be 8 raised to the negative, and again, I'm sorry, not 8, 18 raised to the, it didn't register, got it, to the 1/2, and that would be 1 over 18 to the 1/2, and that is 1 over the square root of 18, which is 1 over 3 radical 2. You could rationalize, not rationalize, that's not a big deal. For now, we just want to get the hang of this. Now, e to the 1 happened to be a value. We normally write e to the 1 to be roughly 2.7, that's more enough. Just like pi is 3.14, we assume either you say that's 2.7 or 2.72. It's a number that's infinite in length, never repeat, never terminates, but we need it for many applications. So for this, we need a calculator. Evaluate the exponential function at x equal negative 2, negative 1, 0, 1, and 2. I'm going to make a chart. I'm going to copy what's in my calculator. So I am going to take x and 5 e to the negative x, negative 2, negative 1, 0, 1. I need a bit more space that we could manage. And a 2. And let's see how that works. I'll get my calculator out. And there it is. And if I take 5, so all what I'm going to do, I'm going to replace whatever x is right there. So since I'm doing multiple things, I'm going to take 5 times, and the e is right there underneath natural log, raised to the negative, this negative, and I'm going to put in parentheses a negative 2. And I'm getting 36 point, how many decimals did it say? 100, 2 decimals. I'm going to copy down 36.95. 36.95. If I go to the negative 1, all what I have to do now, go on my calculator and go back, delete, and put a 1. 13.59. 0. A 5. A 1. $1.84 and 2. 0.68. All right, so that's how it works. All what you have to do is plug in the numbers, and that's that. It's fairly simple and quick. Now, we never talked about this. We want to talk about if you take a function and add a number to it. If that number is positive, the graph shifts up, and if that number is negative, the graph shifts down. If that number happened to be within the function, within the radical, within the absolute value, within the square, within the cube, within the exponential, then this graph will shift to the left h units, and this graph will shift to the right h units. If you multiply the outside, that's multiplying the y by a negative. So, multiplying the y by a number that's stretched or compressed, depending whether c is bigger than 1 or between 0 and 1. Those are important. If you multiply the outside, the y by a negative, the graph reflects with respect to the x. And if you multiply the x by a negative, you reflect the graph with respect to the y. Now, I want to get the graph out of the way, and to do this, I'm going to assume that you've never seen this before. So I'm going to start fresh, and I'm going to say, all right, you know what? To sketch a graph, we learned how to plot points. Let's plot points. I'm going to take this right here, y equal 2 to the x, and I'm going to make a chart, and here's the chart. I'm going to figure out where that equals 0. A point above it, 2 points above it, a point below it, 2 points below it. I'm going to take 2 to the x. I'm going to put a 0 right there. 2 to the 0 is 1. A 1 in there. 2 to the 1 is 2. A 2 in for the power. 2 squared is a 4. 0, 1. Okay. 0, 1. 1, 2, 2, 1, 2, 3, 4. If I plug in negative 1, 2 to the negative 1, 2 to the negative 1 is 1 over 2. That's 1 half. Negative 1, 1 half. And if I go for a 2, I'm sorry, not 2, negative 2. 2 to the negative 2 is 1 over 2 squared. That's 1/4. A negative 2, 1/4. Now, I think I see the pattern to the right. It looks like a parabola, but it's a lot sharper than a parabola. And to the left, there. If I take y equals 3 to the x in comparison, if I put a 0 right there, I'll get 3 to the 0, which is 1. A 1 in there, 3 to the 1 is 3. A 2 in there, 3 squared is a 9. A negative 1, I'll get 1/3. And a negative 2, I'll get 1/9. 0, 1, the same point. 1, 1, 2, 3. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it seems to the right, the shape is the same, a bit more sharp. To the left, negative 1, 1/3, and negative 2, 1/4. So it's beneath it. Interesting. What if I go for y equal 4 to the x? A 0 in for x, that's 1. A 1, 4 to the 1 is 4. 4 squared is 16. A 1, 1/4, and a negative 1, 1 over 16. So 0, 1, it passed through that point. 1, 1, 2, 3, 4. And a 2, 16. Do you see how sharp this graph is? It's heading up to infinity a lot faster. And the points are beneath. Now, to make sense out of this mess, I have one more point to go. If I pick f of x equal x, 1/2 to the x. If I put a 0 in there, I'll get a 1. If I put a 1, I get a half. If I put 2, I'll get a 4th. If I put a negative 1, 1/2 to the negative 1, isn't that 2 over 1? And if I put negative 2, isn't that 2 over 1 squared, which makes it a 4? So 0, 1 is still there. 1, 1/2. 2, 1/4. It seems things switched. Negative 1, 2, and negative 2, 4. So we notice that this graph has shifted. If reflected with respect to the x, if I take the graph of y equal 2 to the x, which is the original blue, and I take the graph of y equal 1/2 of x, do you agree that y equal 1/2 of x is 2 to the negative 1 raised to the x? And if you multiply those, isn't that 2 to the negative x? If you multiply the x by a negative, don't you reflect this graph with respect to the y-axis? There it is, right there. So what do I get out of this? I get out of this, if I see the base to be bigger than 0 and not equal to 1, that indicates this is an exponential function. If the base is bigger than 1, it seems the graph is going to look always like an exponential growth. It seems the graph is going to look something like this, in which the point is 0, 1, and there is an asymptote. We didn't talk about that yet. This line, you can never make y equal 0. And if I chose my base to be between 0 and 1, which is like the 1/2, that's simply taking that graph and reflecting it with respect to the y-axis, and the graph will switch gears and look like this. And that's called exponential decay. If the base is between 0 and 1, we're talking about decay. It's dying out. And if the base is bigger than 1, we're talking about growth. I'll continue this on in the next video.